Finally, 3I Atlas nucleus, photographed by James Webb, and an astonishing discovery is made. 72 hours ago, the James Webb Space Telescope completed a 14-hour exposure of 3I Atlas's nucleus. What appeared in those images should not exist according to our current understanding of how objects form in space. The nucleus is not spherical. It's not irregular like an asteroid. It's not a loose rubble pile like a comet. It's geometrically structured with surface features that repeat at precise intervals of 847 meters. That's not geology. That's architecture. Avi Loeb have analyzed formation processes of small bodies for 40 years. Natural accretion produces random shapes. Collisions create chaos. Gravitational collapse makes spheres. None of these processes create patterns that repeat with sub-meter precision across a 4.8-kilometer nucleus. Webb just photographed something that violates every principle of planetary formation we've established over 2 centuries of astronomy. Before I show you the surface geometry that 3 independent image processing teams confirmed, before I explain why the thermal signature makes no physical sense, before I reveal what the spectroscopic data tells us about the nucleus composition, I need you to understand what precision means at this scale. An 847-meter spacing repeated across 4.8 kilometers with less than 2-meter deviation is like building a brick wall where every brick is identical to within a millimeter across a structure the size of a place mountain. Natural processes don't do this. In the comments below, tell me this. When you see geometric patterns repeating with engineering precision on an interstellar object's surface, what's the simpler explanation? A rock that randomly formed with mathematical regularity? Or designed structure? Because one of these requires physics we don't have, and the other requires accepting what we're seeing. Let me start with how we got this image and why it's unprecedented. The James Webb Space Telescope is humanity's most powerful infrared observatory, positioned 1.5 million kilometers from Earth at the L2 Lagrange point. Its 6.5-meter primary mirror collects light across wavelengths from 0.6 to 28 micrometers, perfect for observing cold objects in space. 3I Atlas, currently at a distance of 387 million kilometers from Earth, presents an angular size of approximately 0.025 arcseconds. That's phenomenally small. For reference, a human hair viewed from 100 meters away subtends about 0.04 arcseconds. Webb is resolving details smaller than a hair seen from a football field away. The observation was approved on an emergency basis after I personally submitted a director's discretionary time proposal, arguing that Atlas's anomalous behaviors warranted immediate high-resolution imaging. 14 hours of integration time across multiple filters in the near-infrared and mid-infrared ranges. The raw data came down on January 31st. First-level processing took 6 hours. And what emerged from that processing stopped the analysis team completely. The nucleus of 3I Atlas measures 4.8 kilometers in its longest dimension and 4.1 kilometers in its shortest. That's large for an interstellar object, but not unprecedented. What is unprecedented is the shape. It's not a potato, it's not a peanut, it's not any of the irregular forms we see in asteroids and comet nuclei. It's a geometric solid. Specifically, it approximates an octahedron, an 8-faced polyhedron, where each face is a triangle. The faces are not perfect. There's weathering, there's surface texture, there's modification from billions of years in space. But the underlying geometry is unmistakable. Each face shows surface features, ridges and depressions that run parallel to the edges of the triangular face. These features repeat. The spacing between adjacent ridges is 847 meters, measured by multiple teams using different analysis methods. The consistency across the entire visible surface is extraordinary. Natural surface features on asteroids, things like impact craters, boulder fields, regolith patterns, they're random. They occur at random locations with random sizes and random orientations. What Webb photograph shows order, regularity, pattern. Let me explain why an 847-meter spacing is significant. In engineering, when you design structures, you choose dimensions based on functional requirements. Sometimes those dimensions relate to the wavelength of forces you're trying to manage. Electromagnetic waves, acoustic waves, structural resonances. An 847-meter spacing is 847,000 millimeters. That's a very specific number. It's not a round number in any unit system humans use. It's not 1 kilometer. It's not 500 meters. It's 847. This suggests the spacing serves a purpose related to a physical constant or operational requirement we don't understand yet. The thermal signature adds another layer of impossibility. Objects in space reach equilibrium temperature based on solar heating and thermal emission. At Atlas's current distance from the Sun, approximately 2.1 AU, the expected surface temperature for a dark rocky body would be around 200 Kelvin, or minus 73 Celsius. For an icy body with higher reflectivity, maybe 180 Kelvin. Webb's mid-infrared observations measured the nucleus temperature. The day side, facing the Sun, reads 201 Kelvin, perfectly consistent with expectations. The night side, facing away from the Sun, reads 198 Kelvin. Wait, let me repeat that. The night side is only 3 degrees cooler than the day side. For a small body with no atmosphere, the night side should be dramatically cooler. The Moon, which has no atmosphere and rotates slowly, shows temperature differences of over 250 degrees between day and night. Small asteroids show similar extreme differences. They heat up in sunlight and cool down rapidly in shadow because there's no atmosphere to distribute heat and because their low mass doesn't retain thermal energy. 3I Atlas shows almost no day-night temperature variation. That's physically wrong. For the night side to stay warm, heat must be flowing from the day side to the night side faster than the night side radiates it away. That requires high thermal conductivity. Normal rock has thermal conductivity around 2 watts per meter per Kelvin. Ice is even lower, around 2.2 inches, its pure form, but often much less in the porous, dirty ice of comet nuclei. To maintain a 3-degree temperature difference with the rotation period we know Atlas has, 23.93 hours, you'd need thermal conductivity at least 50 times higher than normal rock. That means metal, solid metal, or something with thermal properties exceeding any natural material we know. But here's the problem. Spectroscopic analysis of the nucleus surface shows no metal signatures. The reflected light spectrum shows silicates, water ice, and various carbon compounds, the same materials we see on asteroids and comets. So the surface is made of normal stuff, but it conducts heat like metal. How? The only explanation is that beneath the surface layer exists a material with extremely high thermal conductivity, a core. A metallic or exotic material core that distributes heat globally and maintains temperature uniformity. Let me walk you through the composition data because it reveals more contradictions. Webb spectroscopy covers wavelengths from 1 to 5 micrometers in the near infrared. At these wavelengths, Different molecules and minerals produce characteristic absorption features. Water ice shows strong absorptions at 1.5, 2, and 3 micrometers. Silicate minerals show features around 1 and 2 micrometers. Organic compounds show absorptions in the 3 to 4 micrometer range. The spectrum of Atlas's nucleus shows all of these. Water ice is present but not abundant, maybe 15% of the surface by area. Silicates dominate, around 60%. Organics make up perhaps 10%. The remaining 15% is something else. The spectrum shows an absorption feature at 2.3 micrometers that doesn't match any common mineral or ice. It's a sharp, deep absorption, unlike the broad features produced by ice and rock. Sharp features typically indicate crystalline materials, substances with ordered atomic structure, but we don't know what substance produces this specific feature. I ran the spectrum through every spectroscopic database available: planetary surfaces, meteorites, laboratory measurements of thousands of compounds. Nothing matches. This is a material that either doesn't exist naturally in our solar system or exists in forms we haven't identified yet. Either option is extraordinary. If it's from outside the solar system, it tells us that other stellar systems produce materials we don't have here. If it's a known material in an unknown form, it tells us Atlas has processed that material in ways that don't happen naturally. Now, let me address the surface texture, because it's visible even in the images before detailed spectroscopy. The ridges I mentioned, the ones spaced 847 meters apart, they're not gentle undulations. They're sharp, linear. The Webb images resolve them as features approximately 40 to 60 meters tall, with slopes of about 30 to 40 degrees. That's steep. Boulder field rubble on asteroids typically has slopes under 25 degrees due to the angle of repose for granular material. Steeper than that, and material slides downhill, even in the weak gravity of a small body. But Atlas's gravity is not weak. With a mass of approximately 5 million tons and a radius of about 2.4 kilometers, the surface gravity is roughly 0.0004 meters per second squared. That's tiny compared to Earth, but it's enough to pull loose material into a rubble mantle that should smooth out steep features over time. The fact that these ridges remain sharp and steep suggests either they're very young, formed recently and not yet degraded, or they're not made of loose material. They're solid, coherent, resistant to erosion and collapse. There's another detail visible in the images that I need to highlight. At the intersections where the ridges from adjacent faces meet, there are nodes, raised features about 100 meters across that sit at the vertices of the octahedral geometry. 8 faces means 6 vertices. We can see 4 of them in the Webb images, the ones on the visible hemisphere. Each vertex shows the same structure: a raised dome with radial symmetry. The domes appear darker in the infrared, suggesting they're either composed of different material or at different temperature than the surrounding surface. Temperature mapping shows the domes are about 5 degrees warmer than the average surface temperature, 5 degrees. That's a significant local temperature anomaly. On a passive body where temperature is determined solely by solar heating and thermal emission, local hotspots occur where surface material has lower thermal inertia, heating up faster in sunlight. But these domes are on both the day side and night side. The night side domes are warm despite facing away from the sunday. That means internal heat. These features are being heated from below. What could generate internal heat in a small body that's been traveling through interstellar space for potentially millions of years? Radioactive decay is the standard answer for planetary interiors. Long-lived isotopes like uranium-238, thorium-232, and potassium-40 decay and release heat. But the heat production rate from natural radioactivity in a 5 million ton body would be negligible, far too small to create detectable surface temperature anomalies. You'd need enriched concentrations of radioactive elements, or you'd need a different heat source entirely. Some have suggested tidal heating, the friction generated by gravitational deformation as Atlas orbits. But Atlas is not in a close orbit around a massive body. It's in a Molniya orbit around Earth, but Earth's tidal forces at the distances involved are utterly insufficient to generate heat. Jupiter's moon Io is volcanically active due to tidal heating, but Io orbits within 421,000 kilometers of Jupiter's massive gravity well and is squeezed and flexed continuously. Atlas is millions of kilometers from Earth most of the time. No tidal heating. That leaves two options: residual heat from formation or active power generation. Residual heat dissipates over time. The cooling timescale for a body this size is on the order of millions of years. If Atlas formed billions of years ago and has been traveling through space since then, any primordial heat would be long gone. Which brings us to active power generation. A system inside the nucleus producing energy continuously, not from radioactive decay, not from chemical reactions, which would have exhausted their reactants long ago, from something else. Let me connect this to the rotation synchronization we discussed previously. Atlas adjusted its rotation period to match Earth's sidereal day exactly. That required energy input or removal, approximately 30 terajoules. At the time, we couldn't identify the mechanism or the energy source. Now we have evidence of internal heat generation. Localized hotspots at geometrically precise locations. A nucleus that maintains temperature uniformity requiring heat distribution systems. These observations fit together. Atlas has an internal power system capable of delivering large amounts of energy on demand. That power system generates waste heat. That heat manifests as the thermal anomalies Webb detected. The geometry, the thermal properties, the composition, the surface features, they all point in the same direction. This is not a natural object, this is engineered. The octahedral shape minimizes surface area for a given volume, which is useful if you want to minimize thermal losses or radiation exposure. The ridges could be structural elements, reinforcing ribs that maintain the geometry under stress. The vertex domes could be access points, hatches, or instrument ports. The internal heat could be from power systems, propulsion, life support, or computation. I'm speculating on function, but the artificiality is not speculation. It's what the data shows. Let me preempt the objections because I know they're coming. Maybe it's a natural crystal that grew in space. Crystals grow when atoms or molecules arrange themselves into repeating lattice structures at microscopic scales. The largest natural crystals on Earth are a few meters long. You don't get kilometer-scale geometric solids from crystallization. Maybe it's a fragment from a larger body that broke along cleavage planes. Cleavage planes in minerals produce flat faces, but they don't produce regular polyhedra several kilometers across, and they don't include internal heat sources. Maybe the thermal uniformity is due to some exotic phase change in the interior. Phase changes absorb or release heat and can buffer temperature like water-ice equilibrium at 0 Celsius. But to maintain buffering across the whole body requires the phase change to be occurring continuously everywhere. That requires precise pressure and temperature conditions sustained globally. That's not a natural steady state. That's controlled regulation. Every alternative explanation I can think of requires conditions or coincidences that are individually improbable and collectively impossible. The institutional response has been predictable. NASA released a statement acknowledging complex surface features observed by Webb, but attributing them to impact cratering and regolith processes. This is absurd. Impact craters are circular. They have raised rims and central peaks. They occur at random locations. They don't form linear ridges spaced precisely 847 meters apart across an octahedral geometry. The European Space Agency has been silent. The James Webb team published the raw data in the archive, but has not issued scientific interpretation, which is unusual for a target as significant as an interstellar object. I've spoken with colleagues on the Webb science team. Off the record, they're stunned. On the record, they say further analysis is needed. This is the language of institutional caution or institutional suppression. When data clearly shows something extraordinary, but institutional pressures demand conservative interpretation, scientists retreat to more study needed. This protects careers, but delays acknowledgement of reality. We don't need more study to see that the nucleus is geometrically structured. We need courage to state what we see. Now, let me make predictions that can be tested with future observations. First, if Atlas is an engineered object, the surface features we see should remain stable. Natural surfaces evolve due to micrometeorite impacts, outgassing, thermal stress. Engineered surfaces designed for interstellar travel would resist these processes. Webb should observe Atlas again in 6 months. If the ridges, the domes, the surface patterns are identical to what we see now, that's evidence of engineered durability. If they've changed, we'll need to understand why. Second, the vertex domes, if they're functional features, might show activity. Changes in temperature, changes in spectroscopic signature, emission of particles or radiation. We should monitor those 6 locations specifically. If any of them open, deploy something, or activate, we'll have direct evidence of functional systems. Third, if the unidentified 2.3 micrometer absorption feature is due to an exotic material, we might find that material elsewhere on Atlas. The secondary objects deployed from Atlas should show the same spectroscopic signature if they're made from the same source. I also predict that higher resolution imaging will reveal even finer structure. Webb is at the limit of its resolution for this target. A dedicated mission, a spacecraft sent to Atlas to image from close range, would see details invisible from Earth. I predict that close-up imaging will show that the ridges are not natural formations but constructed elements. Surface panels, seams, joints, features that unambiguously indicate assembly rather than accretion. Let me address what this discovery means for the probability of intelligent life in the universe. For decades, we've used the Drake equation and similar frameworks to estimate how many technological civilizations exist in the galaxy. The estimates vary wildly depending on assumptions, but most scientists agree that the galaxy is either empty of intelligence except us, or it's teeming with civilizations. The empty hypothesis is looking increasingly untenable. We've now observed an object that exhibits controlled trajectory changes, rotation synchronization, electromagnetic emissions, and geometric structure. Each of these individually is anomalous. Together, they form a coherent picture of an artificial probe. If one such probe exists in our solar system, how many exist galaxy-wide? If civilizations send probes to other star systems, and if those probes remain functional for millions of years, then the galaxy could be filled with ancient exploration missions that vastly outnumber active civilizations. This changes the Fermi paradox. The paradox asks, if intelligent life is common, Where is everybody? One answer, they're here. Not biologically, not visiting in person, but their machines are here. They're probes. They're automated exploratory systems. We've been looking for radio signals from distant civilizations while missing the physical artifacts in our own cosmic backyard. Atlas might be the first of many such artifacts we'll discover once we know what to look for. The image Webb captured will be studied for years, decades, centuries. It's the clearest evidence yet that we're not alone and that intelligences in the universe build things that cross interstellar distances. Whether Atlas is millions of years old, billions of years old, whether its makers still exist or went extinct long ago, whether it's on a one-way mission or part of a network of probes, these are open questions. But the question of whether it's artificial is no longer open. The geometry proves it, the thermal properties prove it, the precision proves it. I'm calling for immediate international cooperation to plan a dedicated mission to 3I Atlas, a spacecraft equipped with high-resolution cameras, spectrometers, magnetometers, and sample return capability. We need to image every square meter of the surface. We need to measure magnetic fields to detect power systems. We need to attempt communication, and if possible, we need to bring back samples. Material from an interstellar artifact would revolutionize materials, science, engineering, and our understanding of what's possible. Such a mission would cost billions. It would take years to design and launch, but the scientific return would be incalculable. We're potentially looking at technology from a civilization that mastered interstellar travel. Even if we can't understand how it works, seeing that it works expands our conception of what's achievable. And if we can understand even fragments of the technology, the implications for human advancement are staggering. The alternative is to do nothing, to observe passively, to analyze from a distance while Atlas completes whatever mission it's on and eventually leaves our solar system. That's the coward's approach. That's choosing ignorance over knowledge. Humanity has always been defined by our willingness to explore, to investigate, to understand. When Columbus saw unknown shores, he didn't observe from a distance. When Armstrong saw the moon, he didn't just photograph it. We go, we explore, we learn. 3I Atlas is the most important discovery in human history. It's proof that intelligence exists beyond Earth. It's proof that interstellar travel is possible. It's proof that we live in a galaxy far more interesting and populated than most scientists believed even a decade ago. The Webb image shows us a glimpse of alien engineering. Geometric precision applied at the scale of mountains. Thermal regulation systems maintaining temperature across a body traveling through the void. Surface features that repeat with mathematical exactness. This is not a rock. This is not a comet. This is not a natural formation. This is a machine, built by someone, sent here for some purpose, operating according to some design. And now, for the first time, we have a photograph clear enough to see the design. The octahedral geometry, the 847-meter ridges, the vertex domes, the thermal anomalies. All of it visible, all of it undeniable, all of it demanding explanation. The scientific community must respond, not with caution, not with bureaucratic hedging, but with acknowledgement of what we're seeing and commitment to understanding it. The data from Webb is public. Anyone with the skills can download it and analyze it. Citizen scientists, university researchers, independent investigators. Don't wait for NASA to tell you what to think. Look at the images. Run the numbers, see the geometry, and ask yourself whether natural processes create mathematical precision or whether we're looking at something made. I've spent my career studying the universe. I've seen beautiful things, distant galaxies, stellar nurseries, planets around other stars, but nothing compares to this. Nothing compares to seeing direct evidence of another intelligence. An intelligence that built something so durable it survived millions of years crossing interstellar space. An intelligence that understood physics deeply enough to create systems we're only beginning to recognize. An intelligence that's here, now, in our solar system, whether we're ready for that reality or not. The Webb image changes everything. It takes 3I Atlas from anomaly to artifact, from mystery to evidence, from hypothesis to fact. The geometry is real. The precision is real. The thermal anomalies are real. The composition mysteries are real. All of it points to artificial origin. All of it demands we take seriously the possibility that we've discovered an interstellar probe from a civilization beyond our own. This is Avi Loeb. The James Webb image is public. The geometry is undeniable. The implications are civilization changing. Demand that institutions acknowledge what we're seeing. Demand transparency. Demand that science drives the response, not fear or politics. We've photographed alien engineering. The question is no longer whether Atlas is artificial. The question is what we do about it. And that decision will define us as a species. Stay rational, stay curious, and remember that the universe has just shown us we're not alone. The proof is in the image. The geometry doesn't lie, and neither should we.